Hi everyone, today we're going to be talking about the first FRQ of the 2017 AP Chemistry Free Response section. This FRQ mainly talks about gases and gas laws along with kinetics. For this first question, we need to use the ideal gas law. We are given our temperature and our volume in the original part of the question, and in this section we are given the pressure. So we solve for N and we get N equals PV over RT. We plug in our pressure, which is 0.40 atm, multiply it by our volume, which is 25 liters, then we divide that product by our gas constant, which in this case we're going to use 0.08206 liters times atm, divided by mole times Kelvin because we have atm as our pressure unit. Finally, we also divide by our temperature, which is 393 Kelvin. We get 0.31 moles of chlorine gas. For this next question, we have to use the answer from the previous question and use a little bit of stoichiometry. We start with our 0.31 moles of chlorine gas, then we have to use our mole ratio. For every 3 moles of chlorine gas that is consumed, you need 1 mole of the carbon disulfide. Now we have moles of carbon disulfide, so we multiply by the molar mass. In 1 mole of carbon disulfide, there are 76.13 grams of carbon disulfide, so our final answer is going to be we need 7.9 grams of carbon disulfide. For this kinetics question, we have to remember what temperature is. Remember that temperature is the measure of average kinetic energy. Therefore, at a higher temperature, the particles will have more kinetic energy, so they will be moving around a lot more. Not only that, but they'll also have more energy overall to be able to overcome the activation energy. Therefore, there are going to be more collisions with enough energy to overcome the activation energy. Remember that if the temperature is cooler, less molecules are going to have the activation energy necessary to complete the reaction. Therefore, we need to draw a curve where the peak is a little bit to the left of the original one, and the line at the activation energy goes under. So your curve should look something like this. This Lewis dot diagram is extremely easy because we know that chlorine only forms one bond. So we draw a single bond between the 2 chlorines and the 2 sulfurs, and then since we know sulfur wants 2 bonds and it's in the same group as oxygen, we can just connect a bond between the 2 sulfurs. Next, we have to draw our valence electrons around each element to make sure that the total number of electrons equals 8. Due to the pairs of valence electrons on the sulfur, we know that both of the bonds are going to be at the bent angle, which is 104.5 degrees. Remember that hydrochloric acid is an extremely polar molecule, but it's not going to have any hydrogen bonding because the hydrogen is not directly bonded to oxygen, nitrogen, or fluorine. Therefore, it's only going to have dipole-dipole forces and London dispersion. Here we are given that carbon tetrachloride condenses at a lower temperature than hydrochloric acid. This means that the forces in carbon tetrachloride are stronger than those among the hydrochloric acid because since the carbon tetrachloride condenses at a lower temperature than the hydrochloric acid, the intermolecular forces are strong enough to pull the molecules together to form a liquid. Well, that's all I have for you guys today. I hope you enjoyed this video and I'll see you guys in the next one. Take care.